The University of Minnesota defines data analysis as the process of systematically examining data with the purpose of spotlighting useful information. Data analysis is the foundation of scientific research. Conducting a complete analysis allows the impact of the work to be determined, the quality of programming to be assessed, and the results to be communicated to stakeholders. Notice the words in italics. As you go through the steps of data analysis, ask yourself, am I being systematic? Make sure you are documenting your analysis procedures so that someone else can replicate the procedures. From the beginning, make a plan for how you will analyze the data. Is this useful? Think about how others can utilize the results. Use analysis procedures that will have practical application for stakeholders. Does the data analysis have an impact? Consider how findings may influence public policy or programs. The way you report results can have both positive and negative impacts on programs. What do the results of the analysis tell us about the quality of a program or strategy? Assess how results might influence the quality of public health or prevention programming in Colorado. What improvements might be needed? Can the analysis results be effectively communicated to stakeholders? Examine how you might communicate the data analysis methods and results to stakeholders in advance of selecting a program or policy to help guide decisions. With these questions in mind, you can begin your data analysis process. We will go over 4 steps for analyzing data. Step 1 is to articulate the problem you are trying to solve. Step 2 is to consider the type of data you have. Step 3 is to develop a plan for analyzing the data. And step 4 is to see what patterns or trends emerge. The first step is to articulate what problem you are trying to solve with your data. Remember to go back to your assessment steps in Module 4 and clearly outline the purpose of the analysis. You don't want to analyze data without a clear purpose. You should be able to complete this sentence. With this data, I intend to, so that. For example, with this data, I intend to analyze past 30-day alcohol use among high school students so that we can see whether there are differences between grade levels. Or, with this data, I intend to assess how young people access substances so that we can consider the potential effectiveness of passing a social host ordinance. Next, think about the type of data you have in your spreadsheet or data file. Ask these questions. Is your data qualitative or quantitative? Remember that qualitative data is represented by words and quantitative data is represented by numbers. In most datasets, you will have both types of data. What is the format of the data file? Your data file may be in Excel, Word, DBase, Access, Adobe, or another file type. Some formats import easily into statistical software and others do not. Will you need to import the data into another software program to analyze it? Check the Help menu of your analysis software to determine if you have the data in the appropriate format before importing. If you already have your data in Excel and plan on using Excel for analysis, you will not need to worry about this step. Sometimes you need to perform more advanced statistics than Excel can run, but Excel files can be imported into analysis packages. What analysis software do you intend to use? There are many different types of analysis software. You can refer to the University of Minnesota list included in the Further Learning resources for a few of the most common analysis software options and how you can use them. Step 3 is to determine what statistical tests you will use. Summary statistics. In your community work, you will calculate summary statistics more often than inferential statistics. We covered most of the summary statistics, including mean, median, mode, and range, in Module 2. You can calculate these statistics using formulas in Excel. Watch the supplemental Excel video for a walkthrough of some of these calculations. Analyzing epidemiological data. In public and behavioral health, you are often given summary tables that have counts of the number of people who responded in a defined way. From the counts, you can calculate a percentage to determine how many answered a certain way out of the total number of participants. The total number of participants is often stated as N. Sometimes N is the total population when you work with epidemiological data. Here is an example from the U.S. Census Bureau site with data from the 2019 American Community Survey for Durango, Colorado. Notice the percent is calculated for you. The percentage column is calculated by the number column divided by the total population for each category. Managed by the U.S. Census Bureau, data.census.gov, formerly known as American Fact Finder, is a great resource for demographic data. You can run reports for your city, county, state, and national data. A Colorado resource for demographic data is from the State Demography Office, where you can find county and regional data. Inferential statistics. You may need to analyze data using more advanced statistical methods, such as chi-squares, paired t-tests, multiple regression, or others. Take a look at the supplemental table, which provides some basic types of inferential statistics and how they are used in practice. You may come across inferential statistics when conducting a literature review or when you are evaluating the evidence of effectiveness for a particular strategy. When you publish, you will likely analyze data using one of these statistical tests. If you need to run inferential statistics, you can use SPSS or SAS to analyze your data. You can download a free limited version of SAS on their website. Check out the Further Learning section at the end of this module for the link. Some advanced statistical expertise is required when analyzing inferential statistics. Utilizing a local evaluator or statistician may be needed to help you run analyses and interpret results from inferential statistics. Having someone with more evaluation experience review your work will help you learn and become a better data citizen. In Excel, you can calculate percentages easily by typing an equals sign in the cell where you want to do the calculation. Then click on the cell for the numerator, type slash for divide, then click on the cell for the denominator. Let's do this for our data here to see the percentage of naloxone kits that were delivered. We'll type an equals, then click on the cell of the kits delivered, or C2, then a slash for divide, then click on the cell of the kits purchased, or B2. This formula can then be copied down for each row to calculate the percent by site. If you want the denominator to be constant and not change cell locations, you can specify an absolute value. Let's calculate the percentage of the total naloxone kits purchased. You type an equal sign in an empty cell, click on the naloxone kits purchased for site 1, and then divide by the total naloxone kits purchased by clicking on this cell here at the bottom. For each of these site percentages, the denominator will not change, so you can put a $sign in before both the column letter and row number in the formula, so this value does not change as we copy the formula. In this example, the absolute value is cell $B $12 below. You can also use Excel to calculate the average, sum, count, median, mode, minimum, and maximum for a cell range. Let's go through how to calculate an average. Similarly to calculating percentages, type an equal sign in the cell where you want to perform the calculation. Then type average. Now, type the cell range of your data in parentheses and hit enter. You can also copy this down the rows to calculate the average for each row.